Welcome to Mr. Leek's free science tutorials. This video is going to be talking about how to compare the position on the periodic table and the properties of metals and non-metals. Now, the periodic table, this is then a periodic table taken out of the Activate chemistry book. Right, and what this has is it has all sorts of different colours that are going to be linking between the times of discovery. So the yellow ones here are then before 1800, and then the green ones are then the more recent ones that were then discovered within about the last 70 years. Now the key to the periodic table is you have periods. All right, periods are then go across. Groups go down. All the elements on here have their own individual letters, Cu, copper, and they have, just like we watched in the last video, the mass number and the atomic number. Now, what the periodic table is set up like now is it is in order of mass number. So what we have over here, we have hydrogen, helium, lithium, beryllium, which is 3, 4, boron 5, carbon 6, and basically what happens is across it goes up by 1 proton. When it gets to neon, it goes back over to here. Sodium has then got 1 more proton than neon. Proton more, proton more, proton more, and it keeps on going across by increased atomic weight. Right, the number of protons and really the number of electrons. Now, the question itself is to do with compare the position on the periodic table and the properties of metals and non-metals. Now, metals and non-metals, the way I always try and remember it is aluminium is a metal. Silicon isn't a metal, right? And what you do then is you do like a zigzag line that goes down in between them. So aluminium is definitely a metal. Silicon is not a metal. So you've got a line in between there and it zigzags down. So therefore, compare the position on the periodic table and the properties of metals and non-metals. So, this is then the factual information based on it. Metals are to the left of the periodic table, so aluminium and that way. They form positive ions, they are conductors, have high melting points, boiling points, ductile and malleable. Ductile basically means you can stretch it, malleable means you can kind of hammer it into shape. Non-metals are to the right of the periodic table. So where you've got aluminium, everything to the right of it, the zigzag line, is a non-metal. They form negative ions, they're insulators, so they don't conduct heat or electricity. They have low melting points and low boiling points, which tends to mean that they are gases or liquids. Vast majority are gases, right? However, there are a number of liquids and solids within there as well. All right, so back to the question. Compare the position on the periodic table and the properties of metals and non-metals. So, metals can be found to the left of the periodic table, and what they do is they form positive ions. They are conductors, so they are conductors of electricity and heat. They have high melting and boiling points. They are ductile and they are malleable. Non-metals are found to the right of the periodic table. They form negative ions, are insulators of electricity and heat, temperature, right? They have low melting and low boiling points. That then explains, compare the position on the periodic table and the properties of metals and non-metals. Welcome back to Mr. Leek's free science tutorials. Now this question is quite a long question, right? And there's quite a bit of information in it. Explain how elements are arranged in the modern periodic table. That is then the periodic table that you will find in all your textbooks. And what the 2 main steps to get to this were. Now, when you get to the GCSE questions, right, in year 9, 10 and or 11, right, there's a lot more steps and a lot more people involved. Include the discovery of protons, neutrons, electrons and Mendeleev. All right. Now, what I'm just going to double quickly do is just go through and just then have another little look at the periodic table. Just to remind you, going across are the periods. Going down are the groups. Going across the periods, what they do is they go up in the atomic number, which is the number of protons. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, etc., etc. Down the groups, what they tend to be is they tend to be in order of similar properties, and as it goes down, it has one more shell each time it goes down, and it also has the same number of electrons in the outer shell. So for example, lithium has 1 electron, sodium 1 electron, potassium 1 electron, and they're all in group 1. They then increase as they go down in the number of shells. As we go over here, fluorine is in group 7, and for the purpose of this, it's got 7 electrons in its outer shell. So is chlorine, and it carries on going down there, and they're in group 7. Group 8, they all have full electron shells. Now, going back to the question. The question is, explain how elements are arranged in the modern periodic table and what are the 2 main steps to get to this. Include the discovery of protons, neutrons, electrons and Mendeleev. Now, this is then the information. Elements are arranged in order of atomic number. So that was then your 3, 4, 5, 6, 7, 8, 9, etc. Elements with similar properties are in columns called groups. So what they could have done is they could have gone 1 up to 100 and whatever, right? And then it could have just been one long table. But to turn it into a table, what they've done is they've created groups of elements with similar properties. Like I said before, you've got your lithium, sodium, potassium, rubidium, cesium, francium. They've got similar properties. They've got 1 electron in their outer shell, group 1. Elements in the same group have the same number of outer shell electrons, and elements in the same period have the same number of electron shells. So that is then saying, same number of electrons in the outer shell. Going across the period, they've got the same number of shells. Now, how was all this discovered? Before the discovery of protons, neutrons and electrons, elements were arranged in order of atomic weight. Basically, they went across in how heavy they were. Early periodic tables were incomplete. That's because we didn't know some of the elements. Some elements were placed in inappropriate groups if the strict order of atomic weight was followed. So what they did is they made up a periodic table, and then there may well have been just random elements next to each other, right, in a group that had completely different properties. Then what happened is Mendeleev came along, right, and what he did is he left gaps for elements that hadn't been discovered. So the actual elements that were discovered later are your pinks, your orange and your greens. So what he did is he left gaps for the pinks, the orange and the greens. So he did this periodic table with all the blues and the yellows and left gaps. And he left gaps because he predicted that they were then going to exist. So there'd be a huge, great big gap there in between molybdenum and silver. The elements with properties predicted by Mendeleev were then discovered and filled into the gaps. So what he then realised was that manganese and these two here, right, they had similar properties, so then they were put into a group next to each other. Boron, aluminium, gallium, indium and thallium, right, they were also predicted to have similar properties to those. So elements with properties predicted by Mendeleev were discovered and filled in the gaps. Knowledge of isotopes explained why order based on atomic weight was not always correct. Now, what an isotope is where you have 2 different versions of the same element. So where we talked about lithium before, right, in a previous video, what we can then do is you could have an isotope where that 7 would be an 8. It would still be lithium because it's got the same number of protons, but then it's got an extra neutron. So an isotope is basically an element with a different number of neutrons. Okay, now let's go back to the question. Explain how elements are arranged in the modern periodic table, and what two main steps to get this were. Now, you've got it in that, you've got to include the discovery of protons, neutrons, electrons, and Mendeleev. So, this is then the way that you answer the question. Explain how elements are arranged in the modern periodic table. Elements are arranged in the modern periodic table into periods and groups. Periods go across the periodic table. Groups go down the periodic table. Going across the table, right, they are arranged in their atomic weight, right, which is basically the number of protons. The groups are arranged based on their number of protons, number of electrons in their outer shell, and their chemical properties, or the way that they react with things. What were the two main steps that were involved? The two main steps that were involved were, before the discovery of protons, neutrons, and electrons, elements were arranged in the order of atomic weight. Basically, early periodic tables were incomplete. Some elements were placed in inappropriate groups if the strict order of atomic weight was followed. Mendeleev came along, and left gaps for elements that hadn't been discovered yet. The elements with properties predicted by Mendeleev were discovered and filled in the gaps. Knowledge of isotopes explained why the order based on atomic weight was not always correct. So that answers quite a big question based on the periodic table. Thank you.